Okay, so let's talk about the stereochemistry of halogenation. So the halogenation of butane, butane is in more complex alkanes forms a new chiral center, right? So look at this. You've got two hydrogens here, and if one of them gets removed, we've got a hydrogen here, a methyl group, an ethyl group, and a chlorine. So this is a chiral center. And recall that with chlorine, we don't have very good selectivity. So we're actually going to get some of this, and then the R and the S version of that. So we're going to get a racemic mixture plus some of this stuff, right? So it's not synthetically very useful. Now, it's, I guess, looking at how this is added again, whether this is sp2 hybridized carbon, whether the radical is sp2 hybridized, or if it's rapidly interconverting, it doesn't matter. You can see that half of them are going to come here, and the other half are going to come here. So we're going to get the R and the S configurations. I already said that. There's actually three that are produced if we try to chlorinate this. If we try to brominate it, the halogenation of S3-methylhexane, right, it turns out that we're still going to get a racemic mixture because the intermediate, or rather let me go back here, the intermediate, the intermediate is this sp2 hybridized, or I say it's also could be that too, right? But either way, when we get to the if we were brominating, let's see, not brominating, I'm having a hard time talking right now. That and so if we were, sorry, let me just go back here. If we have a chiral center here, and suppose we have not a racemic mixture, right, but optically active 3-methylhexane, then once we pull the hydrogen off, it's going to interconvert, or it's going to be sp2 hybridized. And so we're going to get bromine added to either side. So we're still going to get a racemic mixture. All right, hopefully I said that better the second time around. Now, don't forget the chiral center is a tertiary carbon, and so we will get relatively high yield of the racemic mixture, right? Because this carbon-hydrogen bond is so much weaker than the secondary and the primary. So you can assume, if you're using this for synthesis, you can assume that you'll get a racemic mixture and nothing else, or at least no negligible. At least the contaminants will be negligible.